Hello, my name is Dr. Bugase, and today I'm going to demonstrate for you the mechanical equivalence of heat experiment. This experiment is based on the first law of thermodynamics, which was first discovered by Prescott Joule in the 19th century. Now, in this experiment, we can also determine the specific thermal capacity of copper and brass. And the experiment setup consists of the mechanical equivalence apparatus, which also has a crank handle. We have a clamp that allows us to hold a thermometer in position. We have cylinders, one made of copper, brass, and aluminium. And in them there is a hole that allows us to fix the thermometer and to measure the temperature change due to the mechanical work being done on the system. We also have a dynamometer of 100 newtons, which we will hang onto the system to allow us to measure the force acting on the cylinders. We also have a 10 newtons, and then we have a 5 kilogram mass and a 1 kilogram mass. We need a stopwatch to measure the temperature at time intervals, and then we also have a thermometer that allows us to measure the temperature change. To determine this, we need also a conduction band, which we will wrap around the cylinders so that when we rotate the crank handle, the mechanical energy is converted to heat and the temperature is measured on the thermometer. To do the mechanical equivalence of heat, we use the copper cylinder, we fix it onto our heat apparatus, and then we attach the conduction band to the which we hang on the dynamometer and wrap it around the cylinder 2.5 times, that's 2.5 times. And then we fix our thermometer onto the cylinder. But before then, we put a little bit of our conduction paste to fill the hole in the cylinder and make sure it is properly fixed such that the thermometer points directly into the hole, and to avoid breaking it when rotating the cylinder. Once this is done, initially within 4 minutes, we may record the temperature of the thermometer interval of 30 seconds. After which we will crank our cylinder about 200 turns fast and at a regular speed. And after that, we take the temperature readings on the thermometer and watch it as it decreases in intervals of 30 seconds. And from this, we have determined the mechanical equivalence of heat. To determine the specific thermal capacity of the brass and then the aluminium, we replace them with the copper cylinder on the system in the same arrangement. We record as well the frictional force exerted by the mass on the dynamometer, and then from the temperature rise or temperature change, we're able to compute the specific thermal capacity of both brass and copper. But in the case of the aluminium, we use the 1 kilogram mass, since that is lighter compared to the brass. Thank you.